Solving rational inequalities is similar to solving rational equations. However, we are actually going to, after moving everything to one side, we're going to find the zeros of not just the numerator, but also the denominator. That's going to give us numbers that we'll plot on a number line, and then the zeros from the denominator we'll mark as UND for undefined, and from the numerator we'll mark just as 0 because we know that that's where the whole fraction equals 0. Then we have multiple intervals, and we just need to check if those intervals are positive or negative. So let's go ahead and do an example. We start off by moving everything to one side. So we're going to subtract 5 from both sides of this inequality. Minus 5 is less than 0. Then we need a common denominator here. So we're going to take that minus 5 and multiply it by an x minus 3. And then that will all be over x minus 3. Now we can distribute that 5, so we have a minus 5x and plus 15 all over the x minus 3, less than 0. Combining like terms in our numerator, we have negative 4x, and then negative 4 plus 15 is plus 11 over x minus 3. Now we get the zeros from the numerator and the denominator. So we take 4x plus 11 and we set it equal to 0. And we take x minus 3 and set it equal to 0. So for the negative 4x plus 11, if we subtract 11 from both sides, we get negative 4x equals negative 11. And then divide both sides by negative 4, and we get x equals 11 fourths. For the x minus 3, we just add 3 to both sides, and we get x equals 3. Now we plot these on a number line, and so we've got 3 and then 11 fourths, which is less than 3. Okay, so 11 fourths and 3. And we're going to label these as either 0 or undefined, depending on where they came from. The 0 from the numerator I mark as a 0, and I'm going to go ahead and mark it in quotes so I know this is 0. And at 3, that came from the denominator, and that's undefined. All right, now this splits my number line into 3 sections. And I need to know whether each of these sections gives me a positive or a negative number in this inequality here, okay? So I'm going to plug in just an easy number. I'm going to plug in 0, which is in the number line, it's over here somewhere. So if I plug a 0 in, I get 11 over negative 3, which is a negative number. And so I'm going to go ahead and mark this. This is negative. Now, you can plug numbers in from each interval and do that, or you just need to know what the multiplicity of the zeros that we found are, and that tells you whether we change or not as we pass over these values. The 11 fourths came from negative 4x plus 11. Okay, the exponent on that is 1, which is odd. That tells us that it's going to change as we cross over the 11 fourths. So it changes from negative to a positive. Now, as I move from the positive across the 3, I look at that. That came from x minus 3, which had an exponent of 1. So that's also a multiplicity of 1, which is odd. And an odd multiplicity tells me that it changes as I move across. So now from positive, it changes back to negative. Okay, and now we just need to write our solution. And our solution will be written in interval notation. We are looking for this expression to be less than 0. That means that we're looking for when it's negative. So that's here. It goes to the left forever, so from negative infinity up to 11 fourths. And at 11 fourths, it's equal to 0, but I want it strictly less than 0, so I will not include 11 fourths. We also have this section over here where it's negative, so I have union, and then from 3 to the right forever, so from 3 to infinity. And at 3, it's undefined. And of course, undefined is not less than 0, so we will not include that either. So this is our solution to our original inequality.